decentralized solution, we said it's one unique alternative for facing each one of these situations. At AZUD, we have been working for years in decentralized solution, always focusing on drinking water, wastewater, industrial water, and also irrigation water. So, centralized solution, this consists in one unique solution for different problems. As I said at the beginning, they normally require civil works. They are not transportable. They're usually installed in urban areas and have very high operational costs. On the other hand, we have decentralized solutions, which consist on one specific solution for one unique problem. So in decentralized solutions, you have lower operational costs. As it is a compact solution, you have a better operational control, and it is good for being installed in remote areas. And as I said before, these plants are always relocatable and reusable for different situations. So with the decentralized solutions, we have a number of possibilities. You can work off-grid. These drinking water plants normally include different type of energy supplies, such as solar panels or electrical generator. Another possibility is to have a containerized drinking water plant or water treatment plant. We can have solutions for industrial water treatment, and finally, the wastewater treatment as well. So for off-grid drinking water plants, this is one of the options we have are the mobile plants. And for these plants, you have the option to work, as I said, with solar power, thanks to the incorporated solar panels. You can work with a generator or connected to the electrical grid if available. So say you're working with one of these plants and there's no energy, so you have the sun daylight for 8 to 10 hours, you have the plant working. All of these plants incorporate batteries that will last more or less, depending on the type of water. It could last all night if you're dealing with fresh water. If you are dealing with seawater, it would work around 4 to 6 hours. So when the batteries are run out, you can start up the electrical generator, and during operation, the batteries will recharge in 1 or 2 hours, and you're good to go again. So for 24-hour operation, you would only need, say, 5 to 6 liters of gasoline for the generator. They said these are plug-and-play solutions. You get to the site, you take your submersible pump, and you throw into the well, the river, or the sea, and in seconds, you would have drinking water production. The automation degree for these plants will depend on the need of each problem. So we have fully automated plants that can even include remote control, or we have semi-automatic plants that are also capable to provide the same water quality and that may be needed in situations where you have workforce available, so you don't actually need to have the fully automated plant. All of these have high versatility. As I said, they're capable of producing drinking water quality from any water source, fresh, brackish, or seawater. The same plant will detect the conductivity at the inlet and will activate one technology or the other. In this type of plants, normally the maximum production can go up to 6,000 liters per hour. But as I said, this type of solutions have high scalability. So if you need more, you just add more modules or another plant to have greater capacity. These type of plants are normally used for emergency situations, so it's very important to have components and plants in stock. They can include a trailer for easy transportation. For example, one project that we had to supply was for the disaster of Hurricane Matthew in Haiti, where people were dying from cholera, and we supplied 4 water treatment plants to ensure drinking water quality for all the people. The other option is the containerized drinking water plants. They are also mobile, but the design are thought to be working under the same condition for longer periods. So they are, as I said, mobile, but thought to be working at the same site for a longer period. So the design is thought to maximize the ratio between cubic meters of water produced per day per square meter occupied. So, for example, in one water treatment plant, we can produce up to 1,200 cubic meter per day when using reverse osmosis technology, or even up to 2,000 cubic meter per day when using UF membrane technology when dealing with fresh water. All of these plants always have a robust design. They are thought for tough environmental conditions. All of them have optimized energy consumption. They all include high efficiency pumps, frequency converters to optimize energy consumption. And all of our designs include high-tech membrane that require low pressure and have a high recovery. So the maybe the membrane could be a little bit more expensive, but the fact that it has that requires lower pressure, you have lower energy consumption, so the payback will be in 6 months or a year. All of these plants have different energy alternatives. They can also work with a solar panel, and the designs are for to have minimal of consumables, because we normally use physical filtration as pretreatment, and we try to avoid all the chemical consumptions. So also we have solutions to deal with industrial process water. We have years of experience with a solid engineer team that has allowed us to optimize the design, the energy consumption, and always it could be a containerized with a solution with insulation. It could include air conditioning and heating systems for tough environment conditions. We always use top brand components, so you will always find a local terminal service for each one, and of course the availability of these components if needed. For the industrial processes that require high monitoring, you have the possibility to control online the different parameters of the water treatment process. These plants have easy maintenance that do not require qualified personnel, although we always offer the possibility for training and commissioning of the plant. The low OPEX, thanks to minimum maintenance and low chemical consumption, and of course the optimized energy consumption. Finally, we have the wastewater treatment, where in these cases also containerized with no civil works required. These can be installed anywhere you want. Normally up to 40,000 equivalent inhabitants. It is more competitive than an activated sludge plant that would require civil works. We always use MBBR technology, the moving bed bioreactor. This allows to have more or less 25% tolerance of organic matter load without affecting the system. You always have the same outlet water quality no matter the load that is going into the plant. So for example, the capacity for one treatment line would be for 7,500 equivalent inhabitants. This would be 2 containers, one for the biological treatment and the other used as a secondary decanter, and this allows to treat 1,500 cubic meters per day. All the containers receive an internal treatment to avoid corrosion produced by the wastewater gases. Also, plug-and-play connection. You just connect the inlet wastewater pipe, and it will go through the plant. At the end, you will obtain the water quality required for treated wastewater.